Hi, yeah. In this video, I'm going to talk about how we can use Tabular Predictor for multimodal data. So multimodal data in this particular data set that I'm going to be using, it contains tabular data, which has both text and images. So it's like a combination of all three data types. So here, I'm going to be using the pet finder data set where so the end goal of this is like basically for the rescue shelters to use the predicted adoption rate to identify animals whose profiles could be improved so that they can find a home. So let us start. So the first step is pip install Autogluon and that is happening. And then here we have the data set which I'm loading. And then here we have a zip file and the pet finder processed. And then here inside the pet, we're going to be traversing inside the pet finder process, and you can see there are training images, test images, train CSV, test CSV, and dev CSV. Okay, so basically we will be using the dev data as testing data, as dev contains like the actual data. So yeah, we are checking the training images, and then after that we are just taking both of the data sets. So for the train data, we're taking the train.csv, and for the test data, we are using dev.csv, which is nothing but the actual data. And then we just printed out a few rows out of this. So as you can see, the images, this is the part where the images are there, and this the description is the text. And as you can see, this whole train data is nothing but it's in a tabular format. So it's a combination of all three of them. And yeah, after that, we have the label, which is nothing but the adoption speed. So, adoption speed is nothing but how easy or how fast the animal is going to be adopted. So, yeah. And then here we're just taking the images also over here. So we're just like preparing the image column. And also there's one limitation kind of thing over here that Autogluon supports only one image per row. Mm. Then after that, we're just printing out the train data again. And we just printed a example row and then we're taking the description and then one of the images from one of these examples. And then we're taking the train data, we're kind of sampling it. And then this is where we are doing the feature metadata thing. So you can see that, the description is by default, it came as text. So we don't need to like manually specify that it is a text column. And then the image path comes as images. So yeah, here we're defining the hyperparameters and we're just getting it from this get hyperparameter config. And we mentioned multimodal, so it'll get us whatever hyperparameters we need. And then this is a predictor part. So on based on the train data and all of our hyperparameters, feature metadata, and then we have to give the time limit as well. So we're just making it ready for the prediction, I would say. And this is where the model comparison and the choosing of the best model, everything is done here. Yeah, that is it. And then based on that, we get the best model. So if you can see that the best model over here is the weighted ensemble L2. Yeah, thank you.